Good evening, students. So in the previous two video I have already discussed about the basics of the electromagnetism, the laws corresponding to the electromagnetism. Now today I am going to discuss about the Biot-Savart law. This is the law by which we can basically identify or get the actual magnetic value or magnetic point or magnetic field for a particular current which is flowing through the particular wire, conducting wire. So let us see. So suppose if it is a particular wire through which I amount of current is flowing, and then for this flowing, suppose this is a particular point P where I want to get the magnetic field, right? So let us consider that a small elementary part of this conducting wire, let us consider this part is the del L. Okay, now I is flowing through that particular wire. R is the distance from this elementary part del L to this P point. Okay, this is basically the R. As del L, so from this where a particular tangent is there. This is also del L. Theta is the angle between this del L and R. Okay. And at this point P, let us consider the magnetic field is del B. Okay. So, according to the Biot-Savart law, it is saying that del B is directly proportional to del L. Del B is directly proportional to the I. It is directly proportional to 1 by R square, and this del B is directly proportional to the sine theta. So at a particular point P, we want to find out the magnetic field due to the current flowing through this conductor, right? So therefore, according to Biot-Savart's law, it is saying that the particular point at P, the amount of magnetic field, that is del B, is directly proportional to the del L. I, it is inversely proportional with the R square and sine theta, right? If I combine all these things, so it becomes basically I sine theta by R square. Okay. So this is the proportionality sign. If I want to remove this proportionality sign and make it equal, so a constant has to be there. Let us consider the constant is K. So Ki del L sine theta by R square. So this will be the expression for the del B, for the amount of magnetic field at this point P. Right? Now, if I go for the unit purpose, let me first delete this thing. So according to the Biot-Savart law, this del B is equal to K into I dl sine theta by R square, right? Now if I go for the SI unit, then this del L, make it small del L, this del L and R has the unit in meter. this I is ampere, right? So this del B will be basically Tesla. T, that is Tesla, or sometimes it is known as Weber per meter square. So these two are the unit of this del B. Now coming to this constant K, what will be the value of this K? The value of this K is similar as mu 0 by 4 pi. Now what is this mu 0? It is known as basically the permeability of the free space. When you have studied the electrostatics, there you have studied the terms permittivity, epsilon basically, right? So for that, that epsilon is basically depends on the medium. Similarly, when I am discussing about the magnetic field, there has to be a particular parameter which is dependent on the medium, and that parameter is nothing but this permeability. Okay, so this mu 0 is nothing but the permeability of the free space. Okay, so therefore this del B becomes mu 0 by 4 pi into I del L sin theta by r square. So this is basically the del B. Now coming to the part, what will be the unit of this mu 0? That is the permeability of the free space. The unit is basically defined as Weber into ampere inverse meter inverse. So this is basically the unit of this mu 0. Okay, clear? Now what will happen if the conductor is basically extended? So for the first time I have considered, that is the small del L amount, and as I current is flowing through this conductor, for this small del L amount, the magnetic field we have discovered, that is del B equals to I del L sin theta, mu 0 I del L sin theta by 4 pi into r square, right? Now if the conductor is extended, then what will happen? Then basically this B is converted as summation of del B, because small part del L is there. Now again I am considering this del L, again I am considering this del L. In such a way I have just traversed all the parts of this conductor, and if I getting for this del L a particular del B1, for this del L particular del B2, all these if I sum up, then it becomes del B summation of del B, right? So the value of this B for the extended conductor, it becomes mu 0 4 pi is a particular constant. So I dl sin theta by r square. So this will basically the amount of magnetic field through the extended wire. Okay, hopefully it's clear. So today I am ending here. In the next video I will continue with the vector form of the Biot-Savart law. Thank you.